Alright, so this one changes it up just a little bit. The other one didn't have that X, this one has it. We'll see how we could do it here. Again, you just have to make your call here. Pull the trigger and call something here, U, and call the rest of it a DV. Then apply the dictionary. So I'm going to go with U is equal to X and DV is equal to ln of X dx and see how that goes. I don't know if it'll work or not, but I'm not afraid to try it. So the differential here would be a dx. The v would have to be, I could use the same, I'd have to take the antiderivative of this. See, here's what I'm thinking. To get your v, you have to take the antiderivative of that and the antiderivative of that. Well, I think I just finished doing that in the previous problem, so I'm going to copy it from the previous problem. In case you didn't watch that video, we just did it a little while ago. X ln x minus x. You don't have to worry about the constant now. X, well, let's go with same color. We'll keep it consistent here. Keep it white. X ln of x minus x. Okay? And now what? Now you could say, well, this integral was integral of u dv is equal to u times v, so it's x times x ln of x minus the integral of v du, x ln of x minus x times dx, and so that becomes equal to x squared ln of x minus x squared minus I'm going to distribute this x ln of x dx plus integral of x dx. And now you think, whoa, we just made it a lot harder. Maybe, maybe not. You could say, well, this was the original problem, integral of x ln of x dx. And now it's equal to that whole thing. And then you notice, whoa, wait a minute. That piece I'm not worried about. That piece I can handle. Integral of x is, in fact, I'll do it right now. It's x ln of x dx is equal to x squared ln of x minus x squared. I'll do this one right here, plus, without the funky little things, plus x squared over 2, and I still have that pestering item there, x ln of x dx. And I wonder, whoa, I'm running in circles here because I've got the same problem, the same expression that I started off with. And it pops up over here again. Think, whoa, how am I going to do that? Well, this is a famous trick, and it happens a lot. Especially when you're doing by parts. It's very common to end up with, after a bunch of work, end up with the same thing that you started off with. The perfect remedy for that is so simple. The baby could do it. It's algebra. I'll draw a visual of the perfect remedy for that. So you're trying to solve for some item called A, for example. And then a bunch of stuff works here, you know, a bunch of work goes here, a few hours go by, then you end up with blah, and then you end up with some more stuff, and then you end up with something like plus 3a or something like that, and you end up and say, whoa, I end up with something that you can't see here, 3a, and then you say, whoa, I end up with something that I start off with, that's just as hard as the original one. What am I going to do now? This is crazy. The answer is just to subtract it from both sides, or move it over to the other side and collect it with this one. So you have a plus negative 3a. You see, you put all the a's over here. Then you have your blah stuff here. And then you collect this negative 2a is equal to all this stuff. And then you just divide by the 1/2. And you say a is equal to 1 over negative 2 times all this stuff. That's a famous trick. Whenever you've got something that you're trying to solve for, you do a bunch of work and you end up with the same thing. It's okay, you can just collect all like items over here and then divide by the coefficient. So here, for example, holy cow, what just happened? See? You're a very professional studio here.